All right. I believe I'm recording now. Okay. So you're gonna get like a lot of background noise, and there might be like times where you're hearing me type. I apologize about that. Um, so I wasn't entirely sure which one you needed help with, so I'm just gonna do the two that are on there, and then I have another example for number 20 because they asked this question like more than one way. But okay, so for number 19, it says amoxicillin is a powerful antibiotic. For mild infections, a doctor may prescribe 0.750 grams per day of amoxicillin. What is this dosage in milligrams per hour? So, to figure this out, um, we're going to need to turn our days into hours and our grams into milligrams. So here's how I would do that. If we don't need it on the top, it's going to be on the bottom of the next one. That's what I tell everybody every time we do these conversion problems. So we're going to need grams, and we want milligrams. Let me give the bus a second to go by. So for every 1 gram, there is 10 to the 3 milligrams. Another way that you can see this written is for every 1 milligram, there is 10 to the negative 3 grams. These are equivalent statements, but I prefer to keep positive exponents, so I just have to remember which one is smaller, and that's the one that's going to get the positive exponent. Anyways, so we've turned grams into milligrams, and now we need to turn, we don't want days on the bottom, so it needs to be on the top, and we need to turn that into hours. So for every 1 day, there's 24 hours. And we are going to be left with the units milligrams and hours, which is what they were requesting. So grams will cancel here, days will cancel here. When you do the math for that, shit, I thought it was math I could do in my head. Times 1,000 and then divided by 24, you get 31.25 milligrams an hour for sig figs, which this has 3 sig figs. This is a definition, so it won't count. Same with this. So you're going to go to 3 sig figs, which will be 31.3 milligrams an hour, which would be option B on that you sent me. Okay. For number 20, you have magnesium has 3 natural occurring isotopes with the following masses and natural abundances. Calculate the average atomic mass of magnesium. So super cool part about this, if they're just asking you to calculate the average atomic mass, it's going to be the number that's on the periodic table, but that doesn't really help you if you don't have a periodic table with the same number of sig figs, but you can at least figure out that you have the right answer. So to figure this out, let me zoom down a little bit real quick. You're going to do this. Your average mass, average atomic, equals percent of isotope 1 times the AMU of isotope 1 plus percent of isotope 2 times the AMU of isotope 2 plus percent of isotope 3 times the AMU of isotope 3 plus blah blah. Like if you have more than 3, which you usually won't, you're just going to keep adding. You'll multiply the percentage as a decimal times the AMU as a number. So for here, for our isotope 1, that's going to be 24 mg. It's, here, we'll make a little table here, and AMU, split that down the middle. its percentage is, it looks like 78.99. So as a decimal, that percentage would be 0.7899. You just take the number and divide by 100. And its atomic mass is 23.9850. For the next one, we have, crap, I didn't click on it, oh well. Magnesium 25. And its percentage is 10%, so 0.1000. And its atomic mass is 24.9858. And the last one that they gave you was magnesium 26. That is 11.01%, so 0.1101. And its AMU is 25.9826. So quick thing of note right here, 80% of this average mass, or approximately 80%, is going to be coming from something that weighs 23.9850. So you should be closest to this number. That's just something you want to keep in mind. Whichever one's contributing the most mass, or the highest percentage, your mass is going to be closest to that. And these are only off by like 1 AMU each. So it shouldn't, it might be right around 24. Yeah, the average mass is like 24 point, looking at the periodic table, 24.305. So, I mean, that gives you the answer in this case, but let's work it out. And I just got that from looking at the periodic table, that number that I gave you. Okay, so to find the average, we're going to take, for magnesium 24, we'll take 0.7899 times 23.9850, and it looks like they're using U for yours, plus, now I'm on to magnesium 25, 0.1000 times 24.9858, plus 0.1101 times, oh, where would be U there, 25.9826. So when you do this math, be really careful plugging this into your calculator. I use like shit tons of parentheses when I do this, just to be safe. So I have 0.7899 times 23.9850 plus 0.1 times 24.9858 plus 0.1101 times 25.9826. That gives me, well, the number that I got was 24.30501,576, blah, blah, blah. We should only have, all of these have 4 sig figs, but for some reason your answer has 5 sig, or your choices have 5 sig figs, so we're gonna round to 5. So then our average would be, as I stated earlier, 24.305 U. That would be your average atomic mass. Okay, so there's another way that they can ask this question. What they can do is ask you to figure out one of the percentages instead of your average, or they can ask you to figure out one of the masses of them. So I'm going to show you how to do this because this is usually the one that tends to trip students up the most. Okay, so we have boron has 2 naturally occurring isotopes. Boron 10, it has an abundance of 19.8% and a mass of 10.013 AMU. And boron 11 with the atomic mass of 11.0 AMU. The average atomic mass of boron is 10.811 AMU. What is the percent abundance of boron 11? So, using that formula earlier, the average mass is equal to the percentage of boron 10 times the mass of boron 10 plus, let's put that in parentheses, the percentage of boron 11 times the mass of boron 11. And we don't have a third one here, we're only given 2. So we are being asked to solve for, come on, change for this variable right here. So you want to do some quick algebra, and we'll go the average, and we'll subtract this to the other side, minus percent of B10 times the mass of B10 equals the percent of B11 times the mass of B11, and then we will divide by the mass of B11 because we want to isolate this. So divide all of this by the mass of B11. That will tell us that our percent of boron 11 is equal to the average atomic mass minus the percent of B10 times the mass of B10 divided by the mass of B11. When you put this into your calculator, what I would normally do is write the average minus, and then in parentheses, the percentage is a decimal times the mass, close the parentheses, hit enter, and then use your answer key, or on my calculator I can just press divide by and then put in this number. If you have to, just use your answer key though. And if you need to know how to do that, just let me know, I can help you out with that. But okay, so plugging in numbers. That equals, let me scroll down as far as I can here. The average is 10.811 AMU minus, for boron 10, it would be 0.198 times 10.013 AMU. All of this divided by the atomic mass of boron 11. So here, let me make all of this like crystal clear. This stuff came from here, and then the number I'm about to write came from here, which is 11.0 AMU. And finally, this number right here came from right there. Okay, so that right there will tell us our percentage of boron 11 is equal to, I know the answer, but I want to see exactly what it says, what it comes out to on the calculator. 0.198 times 10.013 equals divided by 11. So on your calculator, you get the percent of B11 equals, you'll get this number, 0.80258, and then it keeps going. So remember, this is a percentage as a decimal, so you'll just multiply this by 100, and that will tell you that your percent of B11 is equal to 80 points. You'll get, let's go, I have 3 sig figs, so we'll go 80.3, because this will be rounded up by this guy, percent. Okay, so I was saying they ask this question and they can sub out like literally any of these variables. So you'll have all of the information but one of these. I can't think of any other way that they would ask that. Oh, there's a quick way to do this as well. But this right here gives you all the steps and it's foolproof. So you know that that B10, the percentage of B10 plus the percentage of B11 is going to equal 100, right? Because those two isotopes in this specific situation make up all of your average. So like if there was boron 12, it would be boron 10 plus boron 11, or the percentage of boron 10 plus the percentage of boron 11 plus the percentage of boron 12 equals 100. So what you can do is just isolate the one you want to solve for. But this way right here is not the way that teachers prefer you to do it, but it's a good way to check your answer, and it takes like 2 seconds. So our percentage of boron 11 would equal 100 minus 19.8, which would equal, in this case, 80.2%. So there's a little bit of a difference here in numbers, but that's because of round off error. This right here was 3 sig figs. This is 3 sig figs, that's 5, 5. So we had to round off at 3 sig figs. But if you look, the next number was a 5, causing us to round up. We would have had 80.2% if we had more sig figs. So that's a good way to check yourself right there. Like these numbers should be super similar. Anyways, I hope this helped. I will send this over to you literally the second it gets done downloading, or uploading, I'm sorry. And if you have any more questions, just let me know. All right, you take it easy.